Welcome to the walkthrough of Assignment 3 Part A for my CS5254 course in summer of 2023. The objective of this first part of the assignment is to learn how to use the Java ExecutorCompletionService framework, which is an implementation of the completion service interface that uses a supplied executor to execute tasks that are placed on a queue accessible using the take method upon completion. Videos describing this framework appear here and here. I recommend you watch these videos to ensure you understand the Java Executor Completion Service. Naturally, we'll also cover these topics in class. In this part of the assignment, you use an instance of the Java Executor Completion Service class that's associated with a cache pool of threads to augment the fixed-size thread pool implementation of the Palantiri simulator app from Assignment 2A. Assignment 3A focuses on creating a cache pool of threads that allow beings from Middle-earth to concurrently gaze into a given number of Palantiri. The Palantiri simulator app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 3A, however, you only need to be aware of the following three directories: Simulator Manager's Being Completion Service, which contains the skeletons you need to fill in, as we'll discuss below; App Source Test, which is a set of unit tests that exercise many Palantiri simulator features and can be used to help test the functionality you implement for the assignment; and App Source Android Test, which is an Android Studio instrumentation test that runs your app automatically. You'll also need to integrate your enhanced solution for the reentrant lock hash map simple semaphore folder from Assignment 2B and use it as the implementation of the Palantiri Manager for Assignment 3A. Please make sure to address all my comments from Assignment 2B in your Assignment 3A solution. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. This app is designed to work with Android API level 33, so you need to select an emulator that uses API level 33. If you don't already have an emulator created that uses this version, you can create it by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Don't change the overall structure of this skeleton. Just fill in the to-do tasks and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the Completion Service folder. Starting with Executor Completion Service Manager.java, where you'll need to complete the to-do tasks in various methods to implement a being manager via a cache thread pool using the Java Executor Service and Executor Completion Service. Next, you'll need to implement the being callable.java file and complete a couple of methods in this class, which should look very familiar by now since you've done it in previous assignments. And then finally, you need to complete the to-do task in the student.kt file to set the type field to either graduate or undergraduate, depending on which version of the assignment that you're implementing. Your app will be considered correct if it passes all the unit and instrumentation tests and all beings successfully complete all their n iterations. A correct simulation should restrict the number of gazing beings to the number of Palantiri. In other words, if there are 4 Palantiri in the simulation, then only 4 beings should ever be gazing on the screen at any time. When the simulation is running, the app view will display visual feedback to show Palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct and doesn't throw any exceptions, then the app title bar labels will appear green when the simulation completes. If your solution is not implemented correctly, or if it throws an exception, then red title bars will be displayed when the simulation completes. Graduate students, or students who are taking this course for graduate credit, must perform the following additional tasks: enhance the Executor Completion Service Manager.java file to use Java streams, method references, and/or Java Lambda expressions, as instructed. Undergraduates are willing and able to implement these methods and features as well, but it's not required. Skeleton code for this assignment is available in my GitHub account. Now that you've set up your GitLab account, you can simply pull this skeleton code into your repository, read it carefully, and complete the to-do markers. Unit tests in the App Source Test folder are provided to increase our confidence that your implementation is working as expected. It's essential that you use the Android Studio GUI to run these unit tests locally on your computer, as described here and shown later in this video. As usual, testing only demonstrates the presence of bugs, but not their absence, so don't rely solely on the test to detect problems in your code. In particular, I'll also provide videos that walk through frequently made mistakes that you should address. Please address these issues prior to your submissions to streamline our programming assignment, review, and assessment process. This part of the assignment is intended to deepen your knowledge of writing concurrent Java programs using a cache thread pool in conjunction with the Java Executor Completion Service. This solution enhances the Java executor completion mechanisms covered in Assignment 2A by eliminating the need for an external queue of futures and ensuring that task results are processed as soon as the tasks complete. Now that we've covered the specification of Assignment 3A, let's go ahead and walk through the skeleton files and examine the various to-do tasks you have to fill in. Everything is located in the Beings Completion Service folder. Go ahead and click into there and take a look quickly at the Being Callable class. This class is very similar to what you've done before, probably in fact identical. And all you need to do is fill in the call method for this Being Callable class to replace null with the appropriate return value, and also go ahead and implement the acquire, Palantiri, and gaze method. And this should use the implementation that you have done for previous assignments, making sure that you've addressed my comments. You might want to watch the frequently made mistakes videos to see some of the examples of things people have done incorrectly with this particular method. Let's now go ahead and take a look at the Executor Completion Service Manager class. As you can see here, there's a couple of to-dos to fill in for various fields. You have to create an executor service, which will be used to contain a cache pool of threads. We'll talk about where that gets initialized later. Don't initialize it here. You'll also have to have a completion service that's associated with the executor service. We'll also talk in a moment about where to do that initialization as well. Let's come down here and take a look at the new being factory method. And this is a method that the beings implement to return a new being callable instance. You need to go ahead and fill this in to replace null with the appropriate code to make the appropriate type of new being. This should also be very familiar to you by now. Here's the run simulation method. This is the entry point that's called by the simulation framework to start the being gazing simulation. There's three methods you have to call. You have to pass in the appropriate parameters. You have to first call a method that uses the executor service to create and start a pool of threads that represents the beings in the simulation. And you have to go ahead and call a method that waits for all the futures to complete. And then you have to call the methods, this class's shutdown now method to cleanly shut everything down. So let's go ahead and take a look at these various methods here. These are some factory methods and helper methods. Here's the create executor service method. This will go ahead and create a cache thread pool executor service instance. Down here, you can see we're going to have the create executor completion service method. As you'll note, it takes the executor service as a parameter, and it goes ahead and creates an instance of executor completion service. And then that gets returned. That, of course, will also be associated with the executor service. Go back and watch the videos if you have any questions about how to do that. Here's the method called begin being thread pool, which uses the executor service and that has the cache pool of threads associated with it. And so you go ahead and write the code in here that calls the get beings method to iterate through all the callables and submit each being callable to the executor completion service instance to go ahead and start things running. And here again, you'll be able to be clever in your use of Java 8 code, such as the for each method and so on. Undergrads can do that optionally. Grad students should certainly do that. I will probably encourage everybody to do it that way because it's good practice to get into, to use the Java 8 features like the for each method and the lambda expressions and so on wherever you can. Then we have another method called await completion of futures, and this will use a for loop or a for each method, even better, to iterate through the total number of beings, blocking on the executor completion service's take method until there's a completed future available. Remember, the way that the executor completion service works is once you get back a future from take, that has already been completed. Otherwise, it wouldn't end up in the executor completion service completion queue. So at that point, you can just get the results and then use it to log whether something worked or not. And the graduate students basically implement the same logic, but of course, make sure that you use Java 8 methods like for each and so on and lambda expressions, and also use the exception utils rethrow supplier method to avoid the need for doing any try catch blocks to handle checked exceptions. So the grad students need to make sure their solution does not contain any try-catch blocks to deal with so-called checked exceptions. They would use the rethrow supplier method, which is a little cleaner way of doing things, quite frankly. So in here, make sure that you put your code in the right place. The undergrad students put their code here. Graduate students put their code in this other section. And then the last method here is just called shutdown now. And you go ahead and tell the executor to shut itself down. That's basically all there is to it. One of the things you'll notice with this particular implementation that's nice is that the whole management of the list of futures that you had to do in assignment 2A disappears completely because that's been pushed into the executor completion service. So it's no longer the application's responsibility to manage these futures using the so-called synchronous future processing model. But instead, we'll let the Java Executor Completion Service handle the completion of the various futures using the async future processing model. So it's a different model. It's actually a simpler model. If you go back and compare this code with the other code that you wrote, you'll see that it's quite a bit simpler and there's less to have to worry about. Probably the trickiest thing is just to figure out how many times you have to iterate through the await completion of futures methods loop. You have to sort of think about that a little bit. That's a little tricky. Okay, so that's basically what there is for beings for assignment 3A. There's also obviously the Palantiri manager. And what you'll do here is just copy over your code that you had written before for assignment 2B, making sure that you first address my comments. So you'll have the reentrant lock hash map simple semaphore manager and all the code that goes in there correctly implemented, of course, and should pass all those tests too. And also make sure you fill in the correct implementation of the simple semaphore class. And a lot of people got this class wrong in assignment 2B, so make sure you fix it for assignment 3A. Of course, make sure you also fix it for assignment 2B, otherwise you'll get points off for that. But make sure that you fix it for sure for assignment 3A and make sure that you're passing all of the tests as well. So now that we've walked through the specifications and the skeletons for assignment 3A, let's go ahead and run the unit tests. You do that as usual by clicking on the Run Tests portion of the folder that has the tests in it, and that will go ahead and begin building and running the tests. You can see how we're coming with the build process along here. There's a lot of tests here, so it's going to take a little bit of time for it to all build. So while it's building, let's go ahead and take a look here. You can see now we're running the tests, and we have all the tests pass. So when you're done with this, you should go ahead and take a screenshot of what you're doing and then make sure you add that to your assignment 3 folder under a name like results.png or results.jpg or however you want to save it. Make sure that you pass all the different types of tests. There's a whole bunch of unit tests here that also test what you have done for previous assignments. So it's very important that you pass all the previous tests as well as the tests that are here for assignment 3A. And some of these tests also include the so-called stress tests, which run the tests essentially in an environment where it's testing it under a lot of threads, trying to see how it performs when there's a lot of contention for the locks and lots of threads are running around doing their thing. And then there's also a whole slew of tests that test essentially white box testing to make sure that your code is doing what we expect. We continually add new tests, so it could be the case that something that passed in assignment, say 2B or 2A, will now fail in assignment 3A. That's not a problem as long as you fix it. We're continually working on ways of improving our testing, so we keep adding new tests. So make sure that your tests are cumulative, otherwise you'll lose lots of points. So that's the end of the walkthrough for assignment 3A. Please let me know, as usual, if you have any questions.